or negative x.
And you're looking at the practice test, right, Sam?
Yeah.
All right, who's got one?
I do.
Go.
2 squared minus 3t plus 2.
How'd you get it?
You just take out the parentheses.
Huh?
You just remove the parentheses.
You mean distribute the negative?
Oh, no, just for this parentheses. So 2 squared minus 3t plus 2, and then you distribute the negative 1 on that. So you get negative 2 squared minus t plus 2. And then you simplify the t squareds into negative 2t, negative t squared. And then you simplify the t's, and you get negative 4t, and then you add the two together, and you get 4.
Excellent. Anybody have any quarrel with Robert's simplification?
Not 4 over e.
All right, let's get to number 2 then. 2A. Sam and Nevin, jump in if you want to do one. Otherwise, I'll go here. Who's next?
Hold on, can we not actually find out what t is in number 1?
Well, there's no equal sign. There's nothing to solve.
We don't know.
Right.
0.
Yeah, it's just an expression. There's no equal sign. Right? It's just an algebraic expression. We're not setting it equal to anything. So no, we can't solve for t. There's nothing to solve.
I can try and do this one, I guess.
You want 2A?
Why not?
You got it. Go. I'm ready. Distribute, right, Sam? Once again, no equal sign, so nothing to solve. Just have to multiply. What's xy squared times x squared? Still there, Sam?
Your mic's off.
Sorry, I was like screaming at the computer. But there was no. Okay, so x cubed y squared minus x squared y cubed plus xy to the power 4. I think.
Let's
then-
check. That sounded good as I was writing it down.
I can now. Can I no, I cannot simplify that.
I think you said it right. I wrote it down. Yeah, the last term is positive. Yeah, I think that's right. Let me just double check the powers. So positive, negative, positive is right. 3 x's, then 2 x's, then 1 x, and 2 y's, 3 y's, 4 y. Yeah, that's right. Anybody have any questions about 2A? Nice job, man. Who's got 2B?
I got it.
You already did one. Got to be everybody. Julian, you want 2B? Let's Bernard, Julian, can you take your headphones off, please? In fact, you should always have your headphones off, just as a matter of common courtesy. All right, so in computer shut down, please. So who's got B? Go. How'd you get it, Jeff?
N minus 1. N minus 1.
Yes. Right, so Jeff is taking advantage of the rule that says a to the m over a to the n is a to the m minus n. So he's just taking the exponent on top and subtracting the exponent on the bottom, right? Right, Jeff? A to the m minus n. And then Jeff just simplified those things. N minus n is 0, and minus a minus 1 is a plus 1. So this is just x to the 1. And y minus, what is y? Why did something stop? I don't know. N minus, y to the n plus 1 minus n. Right now, I'm worried about the first one. I said, okay, n minus. All right, n plus 1 minus n, which is? Jeff thinks it's 1, is he right?
Yes. I would hazard a guess.
There we go. All right, nice job, Jeff. Nice to have you here. What? No, it's positive because you have to distribute the negative here. Yes, minus a minus 1. Cohen, you want the next one?
Oh, that's one, sure.
First, I would distribute the exponents for that.
Here?
equations, yeah.
What does that give you?
That would give positive x to the second over y to the second
Yeah,
times negative 2x to the fourth.
don't forget to
Is that
square
a
the
negative?
-2.
Is that a negative? That is not a negative. Okay. X to the negative fourth over y to the negative.
Yeah. Don't forget to square the -2 as well, right? Everybody gets squared, even that.
Oh,
Yes, really, all the factors get squared.
so then from there, I would simplify
Let's start with the number. What's the coefficient?
coefficient.
Yeah, -2 squared, right? What's -2 times -2?
Minus, no, wait. Yeah, 4.
And x's, you got a 2 and a -4. What happens when you add -4 to 2?
You get minus 2.
Yeah, so it's squared up, squared below. X to the -2 is 1 over x squared.
You put plus.
It is close to. It is x to the -2. Well, I'll put the intermediate step in. It's x to the -2, right? And what about on the bottom? What's 2 and -6?
2 and minus 6. That would be negative 8.
Plus 2 minus 6.
I don't know what I'm looking at. It is negative 8.
It's -4. It's plus 2 minus 6. So
Oh.
2, and you go -6 from there, that's minus. Right. 2 minus 6 is minus. And then we take this guy upstairs and this guy downstairs, and that gives me 4 y to the 4. Right, good. 4 y to the 4 over x. Good. All right. Let's give Marshall the 1 sig thing estimate. You want the 1 sig estimate, Marshall? To officially welcome you to the United States?
Yeah.
I guess you've been here a while. To the Abbey.
So it should be 3.219 multiplied.
Just call it 1, just call it 1. Yeah.
And and 3 multiplied. Yeah, and divide 9 multiplied. The solid.
9 times,
Solid.
yeah, 10 cubed.
And
All right, so let's go with the coefficient first. Don't forget, everything has to get squared here. So what's your coefficient?
9
3 squared is 9, yep.
9 multiplied 10 to the 6.
Yes, times 10 to the 6, x plus minus 1. Then the one on the bottom we subtract, right?
Yeah.
Yeah, all right. This guy looks like 3, right? And then what's my exponent?
2.
Yeah. So it's around 300. Pretty close. That's close to 4. That's pretty close. For a rough figuring. Any questions about what Marshall has done on number 3? Thank you, Marshall. Nice work. All right, so let's go on to 4. Who's got 4? Devin, you want 4? Hey?
Sure, I'll do 4.
So you got a power and a root, right? You
Yeah.
wanna go 1/2 times -3, or you want to go -3 times 1/2?
I guess 1/2 minus 3 times 1/2.
I think this is going to be easier. It's generally easier to take the root first, then the power.
So
The Is that what you want?
Yeah.
All right. I don't mean to lead you into it, but I think that's gonna be easier. Go ahead.
So you put it out, so you get 2 to the negative third, and then that becomes 1/8.
Excellent. All right, if you take the cube first, you can get there. It's just a little trickier. Right, if you do it this way, it's 64 to the minus 1/2. That's actually not too bad, is it? It's 1 over the square root of 64, which is an 8. So it's not so bad, really. Actually, this one is 6 1/2 doesn't really matter which way you do it. Usually, it's easier to take the root first, though. So, all right, let's go to 4B and see if I can find someone that falls into the trap that's been set here.
I didn't, so.
You got it?
Yeah,
You're not going to fall in the trap, though, right?
93.
93. You did fall in the trap. So how'd you get that?
I just added the numbers wrong, 91.
No? Did you do this? So the problem is designed to tempt you to do that because you look at that 3/2 and you look at that 2/3 and you say to yourself, man, I got to multiply those by, that's going to be great because that gives me 1. That's going to make life so easy. But you can't do that, can you? Why can't we do that?
Oh, but they're different bases.
Yeah.
No,
I get that also actually 64 to 3.
that's why, right there. You can't distribute an exponent across addition.
Got a foil.
Yeah, you got to foil it, which in this case is tricky because the exponents are whole numbers, right? So this is a mess. If you can't do that. So what can we do instead, Enda? How about, what's this? Can we just take the root and then the power for this?
Yeah, that is 16.
It is 16. It's 4 squared, which is 16. What about this one? Yes, this is 27 to the 1/3, which is 3 squared. So this is just 16 plus 9. This whole thing is just 25 to the 3/2.
Wait. What did I say?
What's that?
No,
What did I say, Kevin?
no,
What was the question?
no, I was like, I don't know, I heard 16, I was like, 23, that's what I was.
Yeah, everyone see where we got the 25 from? Just work on these individually. Take the root first. The cube root of 64 is 4. So the cube root of 64 is 4. We're taking advantage of that fact because 4 times 4 times 4 is 64. And the cube root of 27 is 3 because 3 times 3 times 3 is 27. So we took, Enda took advantage of those two facts. So 64 to the 1/3 is 4, and 4 squared is 16, and 27 to the 1/3 is 3, and 3 squared is 9. So the number in parentheses is just 25. Now what is it?
Take the square root.
Yeah, take the square root first, and then cube it.
And then you get 125.
Yeah. Oops. Rats.
Is exponential form where like everything's an exponent?
Say it again?
Is exponential form?
Yeah, it just means get rid of the radicals.
Oh, okay.
Yeah.
So that's just.
So whenever you have a root of a radical, is a third and fourth root, you can replace it with an exponential version of the same thing. So go ahead, since you already done half of it, how would you finish it, right?
P to the 4 of the 3rd power times, or yeah, just that,
That, right?
and you can just,
Since this is multiplication, I can distribute now. It's not addition, it's multiplication, so I can distribute. And when I do, I get. What do I get over?
you get. Oh, P 4 over 3, P to the 4/3 power times Q to the 1/3.
Yes. That's a funny looking exponent when you see it. Does it look like an exponent? All right. Let's see. Nevin's done one, Sam's done one, Enda's done one, Jeff's done one. Bernard, how about 6A?
-3.
Excellent. Yeah, 3 to the minus 2 over 2, which is,
2 minus 1, which is 1/3.
excellent, thank you, Bernard. All right, Cohen's done one. Max, you want B?
Sure. B2, okay. So, I have no idea.
Yeah, the problem is, because we normally have situations where either the exponent is the same or the bases are the same. And here we have different bases, 2 and 4, and different exponents, right? Can we figure out a way to write them as both powers of the same base, though?
Yeah, well, it'll be, yeah, it's just a,
That will open up our rules for exponents to us, right?
yeah. So it's just 2 squared on the bottom.
Yeah. Now what, Max? Take the exponent on top, subtract the exponent
Subtract
above.
it, so it'd be 2, to the cube root 3.
Yeah. Yeah, and at this point, you're done. Every year I get a couple guys who want to do this. This is not the same thing. 3 to the 1/2 is the square root of 3, but only if the 3 is in the base. If the 3 is in the power, not the same. Okay? So if you have a radical in the exponent, you can't use the 1/2 power on top of that. That doesn't work. So as long as you stop at 2 to the root 3, you're good. And we talked about 2 to the root 3. It's somewhere between 2 to the 1.7 and 2 to the 1.8. Get as close as you want to get. That's the only way we can really conceptualize what that number would be, because nobody really knows how to raise 2 to the square root of 3 power.
What about B?
What's that?
7B.
Well, let's look at 7 as a whole here. I'm trying to get my scroll bar up here, and no
Oh,
matter
is
where I
that
put this damn darn thing, it gives me problems. So I'm gonna move this down here now. Grab my scroll bar. Come on, scroll bar. So that's why. Now I understand. There we go. All right, there. All right, before we answer your question, Robert, let's look at these guys together. How do these two problems differ? What's the fundamental difference between these two problems?
X is on one side on the line. X is on both sides.
That's true, but that's just that's not key though. That's true, but it's not going to help us that much.
X is in the exponent on the first one.
Yeah. So here the variable is up here in the exponent. Here the variable is down here in the base.
Oh, that's what you do.
Yeah. So whenever it's in the exponent, you use like bases. Whenever it's in the base, you use reciprocal powers. So like bases, the first one, what base jumps out at you? What like base would you just? It looks like a base 2 problem. In fact, it's probably easier to put the bases off for a moment
You just
and
solve
simplify the right-hand side first, and then we'll get it into base 2, because the right-hand side is so easy to simplify. It's x plus 1 minus x minus 2. So provided we can carry that out correctly, we're in good shape. So 4 to the x minus 2 is equal to, what's x minus x is 0. You got 1 minus a minus 2, which is 1 plus 2. So you got that. Now, base 2. What do you think, Thomas? Write this all in base 2 for me. How do you write 4 as a power of 2?
2 squared, so 2x minus 2, or minus 4.
Yep.
And 2
8 is 2 to the,
no, 2 to the 9.
no? This is 8, right? Oh, yeah, I'm sorry. It is 2 to the 9. I'm sorry. You're right. I was just asking how to write 8 as a power of 2. And you were raising that to the 3rd power. So you're right. All right. So this is, on this side, you get 2 to the 2x minus 4 is what you said. And here you said 2 to the 9. So you just went all the way to there, which is great. And then since 2 to the x is a 1-to-1 function, if the outputs are the same, the inputs have to be the same, right? So just solve that, Thomas. What's the solution to that? Yeah. X is 13 halves. All right, nice work. Who wants B? Let's see. Have you got one yet, Patrick? You got B, Patrick.
Alright, so
You want to use a reciprocal power, right?
yeah,
What's the reciprocal of minus 2/5?
2.
Yeah, I put the minus with it so we get a positive one. Yeah, the problem is this pesky 4 out here. It's not actually being raised to the minus 2/5 power, right? It's just hanging out there. It's in the way. So let's move it over to the other side. Get it out of the way. So you just want to have a base to a power on one side, right? And you don't want anything in front of it or being added to it. Get rid of all that. So you just want the base. So let's divide through by 4. And then we have to raise that to the minus 5/2 also. All right, so good. So we moved the 4 over, and we have raised both sides to the minus 5/2, Patrick. What do we get on the left side?
We have
Minus 2/5 times minus 5/2. Why did we choose minus 5/2? What's the product of these two numbers? 1. Yeah, very good. So that frees us from, we don't even need to put the 1 up there anymore, right? So we've freed the variable from its base, from its dungeon, right? The guard up there on the watchtower has been released, so now we can solve for that x. We got to deal with 1/4 to the minus 5/2. I'll give you a hint. We have a rule that says you can flip the fraction and change the sign, right? So I'll do this. Right? You can flip the fraction, change the sign on the exponent. And then you usually take the root and then the power, right? Break the 5/2 into 1/2 times 5. So what's 4 to the 1/2? 2, right. And then what's 2 to the 5th? 2 times 2 times 2 times 2 times 2. That's 4, 8, 16, 32. Doubling. All right, now we're in business, right? Subtract 28 from both sides. And then x is plus or minus 2. Positive or negative. All right, good. Nice work, Patrick. I guess I got these kind of mixed up.
On the test, will you for example, for like plus or minus questions, do you, what happens if you forget like the plus and minus sign right in front of it? Would you still get these
For this test coming up, you'd still get almost entirely. I might take a point off. I might not even take a point off because two things. It's not really relevant to what we've been studying. And secondly, by now we normally would have reviewed that, but we haven't this year because we skipped the bulk of chapter 4 because we got behind last semester. So that would make me doubly disinterested in taking points off. But I might take a point off at most. Yeah, it's not that big a deal. I mean, you really should know moving forward. And for like on a midterm, I might take a lot off. But for this test, it's not really all that important. It doesn't really have much to do with exponential functions, which is what we're trying to get a handle on here. All right, number 8. Let's see. Let's divide number 8 up into pieces. Anybody at home want to do 8A? Winter, you want 8A?
Sure. See. Here, so
Just plug in for x.
Yeah, just plug in 2 for your power.
yeah. So 1 squared is 1, but 9 squared is 81, so it's 1 over 81.
Good. Sam, you want f of 0?
Yeah, it's just, well, if you put it to a power of 0, it's just going to be a 1. So
Yeah, always. Yeah. Go ahead, Julian. What's that?
no, sorry, C would be what, negative 81?
No.
1 over 81, sorry.
No. Flip the fraction. And then
Oh
square.
yeah, oh, so, that'll be 9. Oh, that'll be just a negative, it'll just be negative 81 then.
Nope, no negative. Remember, that negative powers just mean that you flip the fraction. You never get negative numbers. They're always positive. It's just 9 squared.
Can I do
Oh, it's 81.
Yeah. Anytime you get a negative result from a simple power, it's got to be a mistake. It's always going to be positive. And that negative exponent just means take it in the bottom. You want D, Robert? Go.
Yeah, okay.
Thank you,
so-
Billy.
So this is an inverse function, and our output is 81.
Yeah.
So we know that the thing that's going to get us to 81 is f to the negative 2, or the function of negative 2.
Yes.
So we need to do the inverse of the power of negative 2, which is going to be negative 1/2. It's going to be x.
You were on the right track. You had it before. It's just negative 2, right? So here's how I know. If I start with negative 2 and I put it on the F train, problem C tells me that I get 81, right?
Yeah, but are you trying to get out to 1/9?
No, I'm just trying, F inverse on 81 gives me the number that would have taken me to 81 with F.
Oh,
Another way of saying is I'm solving this question, I'm solving 1/9 to the X equals 81. In other words, I'm making 81 the output instead of the input and solving for what the input would be.
so the inverse is, so the function's inverse is the function.
No, it's the one that undoes it, right? So if I were evaluating F of 81, I would plug 81 in here. It'd be 81, it would be, I mean,
It's
it's
just
here.
It's just f negative 1 equals x to the negative 2nd. Yeah.
Say it again?
Wait.
No, it's not a computation, it's an idea. I'm saying F inverse of 81 is the number that I would have to feed to F in order to get 81.
Oh, okay. So
And I already know that's 2 from up here, or mine, sorry.
yeah,
Mine.
so how do we get from 81 to negative 2?
Well, because negative 2 is the power to which I have to raise 1/9 to get 81. So it's the inverse, it's the undoing. So the function itself takes 1/9 and raises it to some power. And the inverse says, okay, I got some number. What number did I raise 1/9 to in order to get that? So look here. If you look at this right here, all I've done here is change the role of the input and the output, right? Instead of raising 1/9 to the 81, I've set it equal to 81 to figure out what power do I have to raise 1/9 to get 81. If you look at this little schematic up here, it's the same thing. What I'm saying is I want the F inverse of 81 is the number that I would have to plug into F in order to get 81.
Okay.
So an inverse function is just a function that undoes the original function. It actually has a name that we haven't talked about yet. So F inverse of X, you're not responsible for this yet. It's called the log base 1/9 of X. We're going to talk about this right after the exam, starting on Friday. The inverse exponential function is called the logarithm. There is no algebraic way to do it. There's no roots or powers or any way to get from backwards, from the result of plugging the power in back to where you started. If you're squaring, you can take a square root. If you're adding, you can subtract. If you're multiplying, you can divide. For exponents, there is no arithmetic or algebraic operation that you know of that accomplishes that. So we have to create one. We have to make up a function that undoes the exponential. We're going to call it the logarithm. That's where we're headed next. But for now, you don't have to actually know it's the logarithm in order to figure out that you're just solving that equation. This is -2. Oops. Don't worry about this. I'm not going to erase it. That's just a preview of where we're headed. All right. This is our first chance really wrestling with the idea of an inverse in a non-trivial environment. So it's going to be tricky for a while. All right. Now the graph of 1/9. We have some points. It doesn't take many points because how rapidly this thing takes off. At 0, we're at 1. That's always the case. So this is 1 right there. 0 goes to 1. And then if we plug 1 in, 1/9 to the 1 is a 9th. So we're already down here close to the x-axis then. at 1. And at 2, we're at 1 over 81. That's so close to the x-axis that we really can't draw it in this crude drawing. So we're almost at 0, almost immediately. 1 over 81 is pretty close to 0. We go another level, 1 over 729. So it almost immediately drops down to the x-axis. It never quite gets to 0, but it gets as close as you want to get. Very rapidly approaches the x-axis asymptotically. If you take 19 to the minus 1, that's the same thing as switch it around to 9 over 1, put a 1 here. That's just 9. So if we're decaying going forward, we're growing going backward in time, and the factor is the power. It's the 9s that we're multiplying. So we go from 1 right to 9, and at minus 2 we're up to 81. 81 is off the chart, literally, right? You can't put 2 comma 81 on this graph without rescaling. So this thing grows very rapidly. It looks just like the decay function as we graphed before, 1/2 to the x. It just decays much more rapidly because of the fact that it's a 9th instead of a 1/2. This is 1/9 to the x.